Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for calculus students who are working through optimization problems, specifically the optimization problems involved in exponential and logarithmic functions. It's section 8.4 in the textbook, and we're going to look here on page 321 at question 2D. Now technically it's question 2A. 2A says use the maximum and minimum algorithm to determine the absolute max and min values for the function in question 1. So it's actually, we're going to be looking at the function listed in 1D. Now question 1 actually says to make the graph of the functions and then use the graph to find max and min. And question 2 then says now do algebra. So we're just going to do question 2. So just a reminder about how we do algebra, or in other words, how we use an algorithm to determine the absolute max and min of a function. We first have to find the derivative of the function, and then we have to find the critical values, and we do that by setting the derivative equal to 0 and solving for x. And then we test the value of the function, any critical values that we found that are in the interval, so in this case between 1.1 and 10, and plus the endpoints of the interval have to be tested and looking for max min output. So obviously the first step is to find the derivative, so let's go ahead and do that. So here's the function. So a couple things. So before I start to take the derivative, I'm mostly going to look at it and see if I can do things to make my life easier here. I'm taking the ln of this sort of complex looking quotient function, which I could do, I guess, but it's honestly going to be a lot easier if I apply the log properties and rewrite this as two logarithmic expressions subtracted instead of one big quotient thing. That's just going to make the derivative stuff a lot easier to deal with. So that's a good first step, and I definitely encourage that. Those properties of logs are useful, and we didn't just learn them because it said to learn them in a book. We learn them for a reason. So now I'm going to go ahead and start to take the derivative. So we have the ln of this expression. So to find the derivative, it's 1 over that expression, and then times the derivative of that expression, which is 2t. And then moving on to the next one, now we subtract, and again we have the ln of an expression, so 1 over that expression. Oops, something weird just happened with my pen. Boom. Let's try to fix that. So t squared minus 1, and then times the derivative of that, which is 2t. And then over here, plus 6 times the derivative of ln t, which is just 1 over t. So cleaning that up a little bit, so I have 2t over t squared plus 1 minus 2t over t squared minus 1 plus 6 over t. So that's what the derivative is algebraically, but obviously I can't really say that I've simplified it, and I certainly am not ready to start solving. So we're going to get a common denominator and try to write a single expression. So my denominator, you're probably saying, hey, how come you haven't factored that? Well, there's no reason to, because this doesn't factor, and it's not like I'm going to find common factors, so I'm just going to leave it the way it is. So my common denominator has to have t squared plus 1, t squared minus 1, and t in it. So we're about to do a bunch of math here. So 2t, I need to introduce t squared minus 1 and t, because it already had t squared plus 1. Minus, so there's 2t, and I had to introduce t squared plus 1 and t, because it already had this one, but not those ones. And then plus 6, where I have to introduce t squared plus 1 and t squared minus 1. And so by doing that, I have this common denominator. So I now have a single fraction. So obviously now I want to do some algebra to that numerator and see how I can simplify it. So I'm going to do a bunch of math, multiply stuff together, collect like terms. I don't think you need me to show you all the steps, but you end up with this, 6t to the 4 minus 4t squared minus 6 over, and the denominator didn't change, but I'll write it because I need to. Otherwise I can't use that equal sign. Okay, so that's what I get. So that's the derivative, and other than perhaps factoring out a 2 on top, I guess I could have done that without you looking, but you're still here, and I'm not in the mood to, I'm not in the mood, I'm not going to edit this video. I don't do that. All right, so that's the derivative as fully factored as I can get. Now I say is fully factored, but I hope you notice that the expression in the bracket on top is a quadratic type expression. This is perfectly in quadratic form. It absolutely fits this sort of concept. It's just that the thing that's squared is t squared. But it is perfectly quadratic in nature, so I need to attempt to factor it, and if factoring it doesn't work, I can even use the quadratic formula if I do this. So I'm just going to continue here sort of on the side and do this math with you. So if I had 3a squared minus 2a minus 3, so in other words I'm doing like a substitution here, but because I'm doing it on the side I'm not formally doing it, so I didn't say let a equal t squared. That's just what I'm doing. So does this factor? Well, no, it doesn't factor. There aren't two numbers that multiply to -9 and add to -2, but I can still solve for a using the quadratic formula. So if you go through all the math here, you do the quadratic formula, get that a is equal to 2 plus or minus root 10 over 3, which means that t squared is equal to 2 plus root 10 over 3, or t squared is equal to 2 minus root 10 over 3. Obviously, I didn't say this, but I've already set it equal to 0. I'm finding critical values right now. Now what happens is over here, t squared, this is a negative number, and I can't square something and get a negative, so there's no solutions from this side. But here, if I do that math, and I'm just going to convert into decimals now, I get that t could be 1.18, or t could be negative 1.18. So those are my critical values. So again, just to go through, I skipped through some math here, but I skipped through just the grade 10 math, that this expression is quadratic in nature. And because it's quadratic in nature, I should be able to determine solutions for the expression t to the 4 minus t squared minus 3 equals 0. And the way I found it was by substituting a equals t squared, solving for a, and then once I found solutions for a, then resubstituting t squared and finding values for t. And so those are my critical values. Those are the values that make the derivative equal to 0. So if we go back, now one of them was a negative, so I don't need to worry about the critical value of negative 1.18 because it's not an interval, but I do need to worry about 1.18. So I have 3 tests to do, 1.1, 1.18, and 10. So in the function, I now need to do my testing. So this is just obviously subbing in, and you can sub into either the original expression or into the transformed expression. So I'm going to do the transformed one. So 1.1 squared plus 1 minus ln 1.1 squared minus 1 plus 6 times ln 1.1. So this is obviously just calculator work. You don't need to see me do it. That's about 2.93. When I sub in 1.18, blah, 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 do the math, I get 2.80. And when I sub in the upper endpoint, was it 10? I get 13.8. So obviously we have a maximum when x equals 10, and we have a minimum at that critical value where x is 1.18. Okay, so I hope that was helpful. Again, key factors in this question are don't forget to apply properties of logs to make your life simpler. Finding the derivative of a quotient would be a lot more complex than what we were able to do here by applying those log properties. Okay, hope that was helpful. Bye.